Hi, I'm Gary Aiken with Kessler Soils Engineering Products Inc. And in this video we want to begin the training sessions for using the Kessler DCP or Dynamic Comb Penetrometer. We're going to be using a K100M kit, but what you see in these videos applies to all of the K100 series DCPs that Kessler provides. To start off, I want to go through the outline for the training videos. This video is the introduction one, and it introduces you to the overview of the manual, the CD that's included in every kit, and the other training videos. After this training video, the next one you should watch is the kit components, which goes through and describes each component that comes in a kit and identifies them as well as the assembly that is required. The next video after kit components is the maintenance, service, and warranty video that explains to you the maintenance, gives you some helpful hints on keeping your DCP in new condition, and helps you understand the warranty as well as how to get service for your DCP. Then the next video is going to be our safety video. Goes through the safety and precautions in using your DCP to keep you and your employees from getting hurt while using the device. Along with that, we'll talk about other safety factors that should be taken into consideration when working on construction sites or around heavy equipment. And finally, the videos on data collection and data reduction, where we show the use of the DCP in the field and how you collect the data, how to use the manual data sheet, and how you can derive your CBRs and your bearing strengths. Okay. So to give you some of the background of the DCP, and specifically the Kessler DCP, which meets the ASTM requirements, these DCPs were built around the patented research from the Corps of Engineers that developed the hammer size, hammer configuration, and the cone shape and configuration to develop the correlations that provide you with your bearing strengths and your CBRs. Okay, in this section we're going to go through the manual. The manual that comes with every DCP outlines two ways of collecting the data. The first one is with the vertical scale, which is what we'll be demonstrating in the data collection video later. And the second one is a DCP without a vertical scale. And it describes how to use each one of those as well as the correlations. The final part in the manual talks about the maintenance, warranty, references to the correlations that are included in the manual, and also a parts list if you ever need to order spare parts. You can order spare parts on our website, the www.kesslerdcp.com. Okay, so let's go through the manual. This should be the manual that you have for your K100. We're going to zoom in here so you get a better view of the pages in the manual. Then on the inside cover is the safety notices that talks about the pinch points, and we'll go into more detail in the safety video with those later, and also the rolling hazard on flat surfaces. The other side is your index, which shows the Part 1 with the DCP with vertical scale, the Part 2 DCP without vertical scale, and the Part 3 that covers the other items that we mentioned earlier in this video. So as you go through, it talks about the application of the Dynamic Comb Penetrometer using a vertical scale. It talks about the 8-kilogram hammer, or since it's a dual mass hammer in this case, you can reduce it down to the 10.1 pound hammer from the 17.6 pound hammer. And we'll show you how to do that in later videos. Okay, moving on, there's a diagram on page 2 of the manual that shows you the configuration of the Dynamic Comb Penetrometer with a vertical scale. Then as you move on into section 2 description, it shows pictures of the dual mass hammer, one with the 17.6 pound or 8 kilogram, and the 10.1 pound or 4.6 kilogram hammer. On the next page, it shows the quick disconnect method of attaching the drive rod to the upper assembly. This allows quick connection between those two pieces and allows you to get to your testing quickly in the field. Then on page 5 over here, it talks about the disposable cones and the adapters that hold the disposable cones while you're testing, and the hardened points that are reusable for multiple tests. Moving to on page 6, it finishes up with the descriptions of the various drive rods that are available and extensions that are available, as well as other optional items such as the magnetic ruler, which collects data for a one-person operation of a dynamic cone penetrometer. Then on page 3, you got the procedures. It talks about equipment checks that we'll go through. We'll talk about those before you go out in the field or after you get in the field to check to make sure your DCP is ready for testing, and will give you valid results. Then the assembly of the dynamic cone penetrometer. Then the drive rods and how to use extensions. Then the testing sequence of dropping the hammer, collecting the data, and performing the test. You have the initial readings here, and then you have the recording methods here of how either you can do it on the manual spreadsheet that's included in the kit, or you can, if you're using a magnetic ruler, it will collect it for you, or you can use your own sheet to collect it. Some pictures of it in use at a site. Then over here it talks about the magnetic ruler a little bit, and then data recording. Finally, back here on page 14 are the correlations that the U.S. Army Corps of Engineers research is based upon, and also the correlations that are based on the tables that are in the manual. So this page here, page 15, is a DCP data sheet. This is the manual collection method. This is what we'll be using today to collect our data. As you can see, it has number of blows, cumulative penetration, the penetration between readings, the penetration per blow, the hammer blow factor. So when you're using the full 17.6 pound hammer, you have a factor of 1. And when you're using the 10.1 pound hammer, then you have a factor of 2. And that later is used to multiply your penetration per blow to give you your DCP index number, which is what you use to look up the CBR percentage. And then if you're collecting moisture, either through a speedy or some other type of moisture device, you can record the moisture over here on the side. Here's the table that correlates with your DCP index to the CBR percentage. Okay? And that's the manual. The second part goes through the same thing without a vertical scale, where you either measure between the 2-inch marks that are on the drive rods, or you mark your drive rod and measure how many blows it takes to go between your marks on the drive rod. And it goes through the same thing. The procedures talks about not using the hammer beyond refusal, and again the correlations, which are the same in both sections. Here you have another correlation table that is usable. Here you have the hammer with the 17.6 pound and the hammer with the 10.1, so the multiplication of the index is not required here. And then you can go straight across with the number of blows to get your CBR based on your soil type, CL, CH, or other. And then the same thing for your bearing strengths, your pounds per square foot on your soil types here. Okay. Here's another table with the correlations, and another one with the correlations here. All right, then part 3 has the maintenance section. That's the first section here. Very short. It's very simple maintenance. We'll go through that in a video and show you how to do that. Then the references that are the basis of the Corps of Engineer correlations. And then the warranty page that goes into details of what the warranty includes and does not include. And then the last page in the manual is the parts list. It gives you the description of the part and the part number, so that it's easy to order them either by calling us or by going online and ordering the replacement parts. No. Okay. Okay, so we're going to go into the final section of the introduction video. We've already covered the contents of the manual in the earlier sections. We've also gone through the listing of the videos that are available for training on the use of the dynamic cone penetrometer. Now in the final section, we want to go through the contents of the CD that's provided with every kit. This CD has 6 items on it. The first item is it has the K100 User's Manual in PDF form to reference or to put it on your computer where you can reference it and look at it. It also has a hard copy of the data collection sheet that we talked about in the manual on page 15, where it has a full-size 8.5 by 11 one that you can print out from that. In addition, there's an Excel spreadsheet where you can load onto your PC and then manually enter your data to calculate the CBRs and to give a chart on where you can see different layers as you've done your testing. You can identify the layers in your soils. So with that, along with that, the mag ruler produces a file that is uploadable into that Excel spreadsheet automatically. There's also Excel spreadsheet instructions of how to install it. It does include macros, so you have to make adjustments in your computer. Most computer setups disable the macros, and you have to enable the macros on that spreadsheet for it to work. And the final item on there is that if you don't have Adobe Acrobat, a reader on your computer, there's instructions also included to be able to download the reader so that you can read the manual and use the data collection spreadsheet. So with that, this concludes the first video of our training series, and I hope you enjoyed it and that you proceed on next to the kit component video. Thank you. Welcome back. This is the second video in how to use your dynamic cone penetrometer made by Kessler Soils Engineering Products, Inc. So we're going to take a few minutes and go through the case of a typical K100 dynamic cone penetrometer that we produce. All of them, all the K100s, are delivered in Pelican cases. Now the Pelican case is protected from the elements, it's good storage, it's shippable, it provides the ultimate protection for your DCP and its components. The other thing, it has the gasketed opening, as well as the valve, the pressure relief valve for atmosphere, as well as the clasp to keep it closed, and you also can secure it, padlock it, if you need to padlock your DCP locked. It has actually 4 places that you can put padlocks on. Okay, the other thing that's handy about the case is you have 3 handles. You have the main handle in the front here, and you have end handles on both ends, including the end that has wheels. Typically, the typical weight for a dynamic cone penetrometer kit from Kessler runs a little under 75 pounds. It can be even down less than that in the 60s, but typically up to 75 pounds. So the wheels come in very handy in moving the cases around. Okay, so let's open up our case. This is our end kit here. And we have the soft foam in the top to hold everything in place. You have the kit that has the molded foam, has outlines for specific pieces of equipment. It also has extra storage locations. It has a long cutout in the back here that you can put extra drive rods in if you have extra drive rods. It also has extra pockets for more disposable cone boxes, adapter boxes, and so forth. It also has box that can either double for the tools, or if you're using a mag ruler, which will fit inside this case also on the DCP, you have the mag ruler printer that can go in that pocket also. Alright, so with your kit, every kit comes with the user's manual and the CD. In the first video, we went through the contents of these to give you an overview of what's provided in these documents. So every kit has that. Okay, to start into the components, the first component is the lower assembly. The lower assembly, it comprises of the vertical scale, which has a measuring side in tenths of inches and also millimeters on the front here. Also included in holding the vertical scale to the drive rod is the upper attachment, which is up here, and then we also have the lower attachment, or foot as we call it, down here at the bottom, that holds the vertical scale in place. Along with this, we have a drive rod. The drive rod in this has 2-inch increment rings to be able to measure if you don't have the vertical scale. Also, at the end of the drive rod in this case, we have the hardened point, the reusable point for performing tests. You can perform up to 250 tests typically with a hardened point before it's worn down and it needs replacement. Okay. The other feature of the drive rod is the cap at the top that acts as the adapter for the quick disconnect that's shown in the manual. Okay. In each kit, we have tools that are provided. Okay. There's you should receive 2 combination wrenches, 9/16, and 1 Allen wrench with a ball hex head on one end of it. Okay, these tools are used to perform maintenance as well as to change out parts on your DCP. Included in the toolkit bag is light oil or 3-in-1 oil, and we'll talk about that during the maintenance section. You also have the pins for the quick disconnect and connect feature of the DCP, of the Kessler DCP. And you have cotter pins for keepers to keep the pins in place while you're performing your test. And we'll show more of this during the testing or the data collection video. But to close out with the tools, every hardened point, adapter, which I'll show you in a minute, and drive rod come with flat spots on the ends. These flat spots allow you to change out hardened points. Zoom in on this and take a look at the details here. So you have the flat spots that help you in tightening and loosening the hardened points and the adapters. For the Allen wrench, there's 2 uses for the Allen wrenches. Okay, one of the uses for the Allen wrenches is to remove the upper attachment from the drive rod. If you're switching out drive rods, you'll have to loosen and remove your upper attachment, and you do that through the Allen wrench and one of the box wrenches. So if we do that, we're going to zoom in here so you get a good view of how that configuration works, where you can loosen them up or tighten them up depending upon what you're doing. Later we'll show you the other use for the Allen wrench, which is removing the donut ring on the 2-part hammer to get you down to the 10.1 pound hammer. We'll do that in a moment. Alright, the other major component on your kit is your upper assembly that includes the hammer, the handle that you're going to use to hold the DCP upright and vertical during testing, and the anvil section down here below the hammer that the hammer impacts when you drop it. Now I'm going to turn the hammer over and show you the end so you get we're going to zoom in here so that you get a good view of the key that holds the donut on to the dual mass hammer. Okay. to make your hammer down to the 10.1 hammer, what you want to do is loosen up that key. Got to hold it. Once you get the screw loose enough, you can go to the ball end of your hex wrench and spin it around and spin it out. And it'll come out very quickly. You want to keep this in a good location. Typically, we recommend putting it in the case so that you don't lose it. After you remove the key, then you can pull the donut up and over the handle and put it aside while you go out and perform testing with the 10.1 hammer. So when would you use this hammer? You use this hammer typically when you have very soft soils. That if you, with the standard hammer, the 17.6 pound hammer, is driving your drive rod down 4 inches, 6 inches, or more at a time. You know, your very soft soils, peat conditions, stuff like that would require you to go to this lighter hammer so that you can determine your layers. And that's the primary purpose of going to the lighter hammer in weaker soils, is that it'll give you a better differentiation between where the layers are getting a little stronger or a little weaker as you perform the 36-inch or 30-inch test. Okay, so those are your major components. The other parts that we need to talk about in the kit that comes with every kit are adapters. We're going to zoom in here on a box that shows the adapter. Okay, each box will, if you have multiple adapters, there'll be the quantity on the box. So inside, an adapter looks like this. This is what your typical adapter looks like. Threaded on one end to thread into your drive rod, has an indent, flat end on the other for the O-ring. This is the O-ring to go around that and onto that adapter to hold the disposable cone in place. The disposable cones look like this. They come 25 to a box. When you order an M kit, you get 4 boxes or 100 disposable cones. These are single-use cones. When you drive the cone into the soil down at the bottom of your test at 36 inches, this cone will pull off of the adapter and stay in the soil. Now it's made tight to keep it on there while you're driving, because if you have a stone or something on the side of it, it won't knock it off. So it's very secure. As you can tell, when I was putting this one on, I was twisting it as I put it on. That is one of the techniques to get it on there. The other technique is to have your adapter on the drive rod where you can grip the drive rod more and to be able to twist it on there. A little tip also is to keep your gasket, that little O-ring, in good condition or better condition, to put a drop of the 3-in-1 oil on those O-rings. After you roll them onto the adapter, just put a drop on there, rub it with your fingers or a paper towel to take the excess off, and that'll keep the O-ring from getting torn up as easily. Every disposable cone box comes with another O-ring. So an O-ring should last you about 25 disposable cones per use, and then you'll have to replace it. Here's a box of the disposable cones. So this concludes the kit components for a Kessler Soils Engineering Products Inc. Dynamic Cone Penetrometer. Hi, in this section we're going to discuss the maintenance, service, and warranty sections of the manual for your Kessler Soils Engineering Products Inc. Dynamic Cone Penetrometer. We're going to start off with the maintenance first though. The DCP is relatively maintenance free, but there are a few things that you need to tend to in order to keep your DCP in good operating condition, and it will last you a long time if you do these things. Most of them revolve around using the 3-in-1 oil that is provided with you in the kit. The first area that the 3-in-1 oil should be used is in lubricating the threads to your adapters and your hardened points that thread into the bottom of your drive rods. Okay? And basically all you want to do is just put a drop on there and then thread them into the bottom, and I'll show you exactly what we're talking about here. We'll use our wrenches to loosen the hardened point, like this. So when you have a hardened point that's been worn, that the 3mm edge is not discernible, you can't see it any longer, then you want to replace it with a new one. Every time you replace a new one, take your 3-in-1 oil, just put a couple drops on it, and then thread it right into the drive rod. Couple things. One, it'll keep the threads clean in the drive rod, and it also makes it easier to install the hardened point. Then after you hand thread it in, then the last thing you want to do is just give it a snug fit with the wrenches on there. The same goes for the adapter. Just a drop on each time you put an adapter in, thread it up into the drive rod, and that'll keep the threads in the drive rod clean for you. The other use for the 3-in-1 oil is to clean your drive rod. After each use or each day, you should clean your drive rod. And sometimes you have to extend the lower attachment up to be able to clean down here around the hardened point or the adapters. But what you want to do is put a little bit of oil on your rag and just run your rag up and down your drive rod to keep it clean. And then of course you want to do it up here at the top also. Like that. Alright, so that'll keep that nice and clean. Obviously before you do the oil, you want to get any mud or any grass or any other debris that is attached or clinging to your drive rod. You want to remove that. Alright, the other place and the final place for the oil is on the upper assembly. And you want basically the same process as the drive rod. You want to take your rag, put a little bit of oil on it, and run it up and down your drive rod to keep it nice and clean. And then the same thing where the hammer is. You want to do that area too. What this will do is keep the rod clean and prevent any scarring of this rod with the hammer. One of the key things, and there are requirements in the ASTM for the dynamic cone penetrometer, is this distance from the anvil to the bottom of the handle, along with the weight of the hammer. And you want to take good care of that by keeping this rod clean, so that you maintain not only the distance but the weight of the hammer. The hammer is a plus or minus 10 grams, so that's how tight of a tolerance it is on the hammers. Each one of these items are checked prior to the shipment of each DCP from our factory to ensure that the ASTM requirements and it's within the ASTM requirements and tolerances for the DCPs prior to shipment. Okay. Some other helpful hints is to use the oil when you have an adapter and you have an O-ring. When you put the O-ring on, if you do it before you put it on, it will make it much more challenging for you. But once you put the O-ring on, just put a drop of oil on the O-ring, rub it with your fingers, and then rub it with the paper towel or cloth to take the excess off. This will help increase the life of your O-rings in there for that. Okay, moving on. The other maintenance items that you want to do is you want to be able to check the straightness of your drive rods. You should do this prior to beginning a day's worth of testing or a new group of tests after you've been transporting the device. You do that by two methods. One method is to compare it to your vertical scale. Are they parallel? Do they look parallel? Is there any bowing or bends or kinks in either the vertical scale or the drive rod? So you want to look at it in both directions, turn it 90 degrees and check it. And if it looks straight, then you'll get reliable results. The other method is by rolling the drive rods. And what you want to do is take a drive rod outside of the vertical scale, and on a flat surface you want to roll it. You want to see if it rolls nice and straight. The gap between the flat surface and the drive rod stays the same to indicate that it is a straight drive rod. So that's your care. So every day, prior to testing or before a group of testing, there's two steps you need to do. One is your drive rod straightness check, and also your hardened point if you're using hardened points. And on the hardened point, you're looking for two things. You're looking for the maintaining of the 60-degree angle on the cone shape, and that the 3mm edge or lip around the edge of it is still discernible. Those are two critical factors in making and giving you valid results in the test with the DCP. So if you have both those and you're ready to start your testing, and this concludes the maintenance portion of the training. In this section, we're going to cover warranty and service. Page 30 of the user's manual outlines the details of the warranty coverage. Typically, it's for 12 months for all the parts and pieces to your dynamic cone penetrometer, and includes covers any defects or manufacturing problems that may come up during that time period. I recommend that you read the details of there, because there are some limitations regarding misuse of the device that would not be covered under warranty. Service. So on the next page of the manual, page 31, is a parts list that gives you the parts name and number for each of the items in your DCP kit. This is an easy reference, so when you call and you need spare parts or you need additional disposable cones, you have the part number handy right there. You can contact or you can order spare parts online with our online store at www.kesslerdcp.com, or you can call our 800 number for service also, and we'll be more than willing to ship you out the spare parts or also the disposable cones. Typically, if we receive your order by 3 p.m. East Coast time, it'll ship out the same day. Okay, now we're just about ready to start collecting data in the field. But before we go out in the field, we have a short safety message that every user of a DCP needs to be aware of. There are several pinch points on a DCP that can injure you during your operation of the DCP. So with that, most of them are in the upper assembly, and I'll pull it out. Now you'll note when you pull it out of the case, you need to be careful and keep the hammer balanced between your two hands. There's two handhelds formed into the foam of the case to help you do this. By keeping it balanced, it avoids the hammer from sliding down and hitting one of your hands, or even pinching it on the anvil or the handle by getting it out of balance. So we pull it out, balanced. Okay. So with this, the other safety considerations and concerns that you should be aware of is that you have a pinch point at the bottom of the hammer. When you're dropping the hammer, it comes in contact with the top of the anvil. So this is a pinch point. You need to keep your free hand clear of this area during your testing. So that what you'll see out in the field, the technique to use the hammer is you'll have the hammer at the top and you'll drop it, and what you'll do with this hand is pull it away and keep it free from the device so that you know it won't get pinched when it lands on the anvil. The other pinch point is when you're doing extraction of your drive rod from a test hole. And what happens is you use the hammer to impact the bottom of the handle. What you want to make sure is when you start that operation is that all your fingers of the hand that's holding the handle is above this ring in the handle. That's why that ring is there, is to keep those fingers from slipping down and getting pinched with the hammer and hitting them with that. The other hazard, and then again it associates with the hammer, is that if you assemble or even have your parts and pieces for your dynamic cone penetrometer laid out flat, such as in the back of a pickup truck or on a tailgate of a pickup truck or another vehicle, it's a flat surface and it can easily roll off onto your toes on the ground. So what we recommend is that you carry, store, and use the Pelican case that comes with your DCP kit to avoid this hazard. And by taking the items apart and putting them directly into your case after you've finished your testing will prevent that hazard from occurring to you. The last item in performing dynamic cone penetrometer tests in the field, you always need to have your personal protective equipment with you. Whatever's required by the project or your company or the requirements, but typically you always have your hard hat and you have a safety vest. Safety vest is critical for visibility when there's heavy equipment or large vehicles working the site. So as a minimum, check with the project, the company you're working with, on what the requirements are, and always wear your personal protective equipment when you're working in the field. Welcome back. We're about to start the demonstration and training for the Kessler dynamic cone penetrometer of how you take readings in the field. The first step, though, that we want to show you is the assembly of the DCP. You're at the field, you have your case open, and we're going to start putting the dynamic cone penetrometer together. So you reach in, use the handholds to pull out the upper attachment that includes the upper assembly that includes the hammer. In this case we're using the single mass hammer instead of the dual mass that we showed you earlier in the kit components. Then you got the lower assembly where you're going to attach them through the quick disconnect using the pin, and then the cotter pin to connect them. And let's zoom in on that once you get it connected, so that you have a feel for what it looks like. Okay. Alright, good. Alright, so now you're ready to go in the field and to start taking tests. We have our clipboard with the data sheet that's from the CD that's provided in the kit, the full size that we talked about. And we're going to get a close shot of that. So it's a full size one there. And then we're ready to start our testing. So we're going to go right over here to the side and set it up and get it ready. We're using a hardened point for this demonstration and testing. There's the hardened point. Okay, so before starting, we check the straightness of our drive rod, and we check the 3mm edge on our hardened point. Okay, we're in the field now. We've got our dynamic cone penetrometer set up. It's vertical, and we're about to start the testing. There's a couple of things we need to go through before we start the testing. One is the lower attachment or foot needs to be placed in a level spot on the ground, and also don't run the hardened point or the drive rod into the ground. Allow the hammer to do the driving for you. So it just wants to sit on a level spot, and the point will be right there on top of the surface of the soil. The other thing that you want to do is, of course, take your initial reading with the upper attachment or the black vinyl attachment that is pointed to right now. And when you take these readings, you can either take them at the top of the attachment or underneath the bottom of the attachment. The key thing, though, is that you take the reading from the same side, the top or the bottom, throughout the entire test. So with that, we're going to take the initial reading. I'm going to record it on our data sheet that we showed you earlier, and then we're going to proceed with hammer drops.
64 millimeters.
Okay, so we're going to take a reading after 3 blows.
141 millimeters.
Okay.
$190 millimeters. 2 blows. Two blows, 234 millimeters. Two blows, 290 millimeters. Three blows, 352 millimeters. Three blows, 408 millimeters.
So roughly we're taking readings about every 2 inches. Every 50 millimeters we're taking readings and collecting the number of blows it takes to go those 50 millimeters. So we're going to continue with the test till we go to the full 36 inches.
Three blows, 458 millimeters. $513 millimeters.
Okay.
$562 millimeters. Three blows, 632. Correction, 636 millimeters. 686 millimeters.
Okay. We're almost done with the test, but we're going to get all 36 inches in.
Three blows, 762 millimeters. Two blows, 865 millimeters.
Okay.
Two blows, 928 millimeters.
And this will be our last wrap, in fact, right there. So you had one blow and...
One blow went down to 953 millimeters.
Okay. All right, so now you've completed the test. You've driven the drive rod, the full length of the drive rod, and the vertical scale. You can see here how the upper attachment has matched up to the lower attachment, or the foot, at the bottom, and the vertical scale is standing up almost parallel with the handle. So the next step after this, after we collected our data, is to extract the drive rod from the test hole, and we're going to demonstrate that of how you do this safely by retrieving it from the hammer. So you see where the hands are free, clear from the handle and the impact zone and that pinch point up there. So once you get up to a certain point, then you can, with a soft soil like we have here, you can almost pull the device up and out of the ground. There we go. Okay, the next section here, we're going to show how you use the DCP when you don't have a vertical scale or a magnetic ruler to collect your data or to give you numbers. So in this case, you're relying upon the 2-inch marks that are on your drive rod, and we're going to measure that and use the tables that are provided for you in the manual to determine CBRs and the bearing strengths. Okay, so to get this test started, what you have to do is get the drive rod to a point where you have one of the rings at the surface of the soil, and that's what we're going to do right now, is to seat it to one of those rings. So that's why you see the little hammer drops here, is to get it to the first ring before we start our testing. And I think we're there. So we're going to begin the testing. So in the manual, if you look on the manual on page 23, 24, and 25, you have three tables. Table 3 that tabulate the correlations for 2-inch penetrations. Then table 4 is for 4-inch penetrations, and table 5 is for 6-inch penetrations. So we're going to begin the test here, and we're going to utilize the table to give us our results when we go through each of the 2-inch rings. Or if we go through more than one, then we'll use the other tables accordingly.
One blow, 2 inches.
Okay, and then of course you want to record this data, and you can use the tabular sheet to do that.
3 blows, 2 inches.
3 blows, 2 inches. So now we can go to the table, and we can look on the table 3. We've got the 17.6-pound hammer. We did 3 blows per 2 inches, and you come over, and we're saying we've got a CH soil here, high plasticity clay. Gives us a CBR of 21 and a bearing strength of 4,060 pounds per square foot.
Four drops, 2 inches.
So again, going to the 2-inch table on table 3, 4 drops would give you a CBR of 27.
Two drops, 2 inches.
Okay, so now we've sort of gotten back into a soft layer. And if you go to 2 blows on the table 3, it will give you a CBR of 14.
Three blows, 2 inches.
So again, that CBR would be 21 based on table 3. Now, when you're doing testing, you will come across situations where you hit rock, or you hit a stone or boulder in the ground, and it prevents you from driving the rod further, or point of refusal.
6 blows, 2 inches.
So with 6 blows going down, the CBR now jumps up to 41, because there was probably a rock or a hard layer there that we hit.
Four blows, 2 inches.
So 4 blows, 2 inches on table 3 is 27 for the CBR.
Three blows, 2 inches.
3 blows, 2 inches is 21.
Four blows, 2 inches.
So we're back to 27 again. So with this, what you would do is you would keep driving this with your 2 inches through the depth that you want to investigate, or to the length of your drive rod. So if you're using a 30-inch drive rod, it'd be the 30 inches, or the 37 3/4 inch one will give you your 36 inches.
3 blows, 2 inches.
And that's 21. So this gives you a feel for how you do the testing, collect the data from without a vertical scale and a magnetic ruler. We're going to stop the test here and extract the unit, and then in our next video we're going to show you at the end of the day or end of a testing period of cleaning up your DCP and putting it back in the case. So you've completed your testing for the day. You're ready to put your device back into the Pelican case. So what we want to do is just show you the cleanup process for your drive rod, especially removing the mud and soil that may become attached to it, and that's what we're going to show you right now. It's not necessary to put oil on it every day. However, periodically, once a week, if you're using it every day during the week, is fine for applying the oil on the drive rod. At the same time that you're doing this, what you also want to do is take a look at your hardened point to see if it's been damaged or worn down, and then you can do the replacing of it at the end of the day and be ready to go on your next testing there. In this section, we're going to go through the data reduction. Normally this can be done out in the field, but to be able to see what we're doing, we're going to do it here inside. But the kit, the owner's manual, and the data sheet is set up where it can be done as you're collecting the data. You can fill out the columns. So what we're going to do is go through a couple of the columns, and then we're going to show you the completed data sheet for the testing that we did out in the field. What you see on the left here right now is the data sheet that we filled out when we demonstrated the DCP out in the field a few minutes ago. We also have a calculator, a pen or pencil, and also the user's manual. And specifically, page 16 is the page that we want to go with in the user's manual, table 1. It's the end of part 1 of the manual where you're using the vertical scale. The other thing before we get started I'd like to point out is on the data sheet, it has directions or instructions at the bottom of it for each of the column numbers. Each column is numbered at the top here, 1 through 8, and there's a corresponding number down below that gives you instructions for that calculation of how to perform that operation. So to start off, what we're going to do, we started at 64 millimeters. So what we'll do, just to keep everything straight, we draw a line through that. You can, if you want to, you can omit that from your table and just carry it up above here where it says depth of 0 point below surface at 64 millimeters. So, but in this case we went ahead and recorded it. It's easier to just have all your data recorded together. So the first operation is you want to start filling in column 3. Column 3 is the penetration between readings in millimeters. So what that is, that'll be your 141 minus your 64. So 141 millimeters was the cumulative penetration minus the 64, your starting point, gives you 77 millimeters. So that basically, the drive rod went down 77 millimeters in 3 blows. So the next step for column 4 is penetration per blow in millimeters. So it's taking the 77, dividing that by your column 1 number of blows to give you 25.6 or 26. You can round up to the nearest millimeter. Alright, then column 5 is your hammer factor. And as you can read down here at the bottom, you enter a 1 if you're using the 17.6 pound hammer, or a 2 if you're using the 10.1 pound hammer. In our case, we were using the 17.6 pound or 8 kilogram, so we're going to enter a 1 into the hammer blow factor, like that. So now, column 6 is the DCP index of millimeters per blow, and that is based upon basically taking column 4, penetrations per blow, times the hammer blow factor number. So in this case, it's 26 times 1, and you end up with 26. So if you're using the full hammer, the 17.6 pound or 8 kilogram hammer, then these two columns will match, columns 4 and 6. At this point, for column 7, you need to go over to the table in the user's manual, this table 1. Okay, it's on page 16, table 1, and it's right before the start of the next section in the user's manual. So what we'll do is look up our DCP index. So you can see where 3 goes up to 20, 21, 22, 23, 24 through 26 is a CBR of 8. And that's what you would enter in column 7 is the CBR of 8. Alright, so we're going to go through and do one more row like this, and then we'll show you the completed product after that example. So going again for your next reading, we have a cumulative of 190 millimeters minus the 141 millimeters, giving you an incremental or penetration between readings for column 3 of 49. Alright, so then penetrations per blow, take your 49 divided by the 2 blows that it took, 2, gives you 26. No, I'm sorry, 25. So then 25, your hammer factor is 1. Your DCP index, again going to the table, 25 is in that range of 24 to 26. So it's a CBR of 8 again. Alright, we'll do one more here. We'll do 234 millimeters minus the 190 millimeters gives you 44 millimeters for 2 blows. So divide the 44 by 2, gives you 22. Hammer factor is 1. DCP index then is 22. And then referring to the table, 22 is a CBR of 9. So you keep doing this until you complete all your testing, all the data that you had, and reducing it, and it'll give you your CBRs. When you have that, it looks like this. This is the finished spreadsheet here, where we've gone through, we've got our penetrations between readings, we've also got our penetrations per blow, the hammer factor was the same, the DCP index in this case, since the hammer factor is 1, is the same as the penetration per blow, and you can see your corresponding CBRs. What you want to do after you see your CBRs, then you can start going in and where you have differentials between the CBRs, where you have a stronger layer of soil versus a weaker layer of soils, you can start seeing the layering effect. This has also helped with the graph in the Excel spreadsheet that's provided on the CD with the user's manual. So it will help you in determining where the layers are, where a strong layer is. It'll also highlight if you have a soft layer that is underneath a stronger layer of soil. So with this concludes the training class for the Kessler Soils Engineering Products, Inc. Dynamic Comb Penetrometer. If you have any questions, feel free to contact us either at our website, www.kessler.com, and we'll help you out and respond to you as quickly as we can. Thank you.